What happens when sulfur dioxide and oxygen gases are mixed in a sealed container? When sulfur dioxide and oxygen, which are the reactants, are mixed together in a sealed container, they both chemically react to produce sulfur trioxide, that is a product. This reaction is a formation or combination reaction. This is the chemical equation showing the reaction between SO2 and O2 and formation of SO3. But this reaction is not a complete reaction. It gives reversible reaction. But how? Let's see. At the beginning of the reaction, we have only sulfur dioxide and oxygen. There is no SO3 at the start. So reaction goes to the forward direction from left to right in order to make the product. At the start or initially, rate of formation of SO3 is highest, means rate of forward reaction is highest due to the highest concentration of reactants SO2 and O2. But as time passes, concentration of SO3 increases and SO2 and O2 decreases. Due to this, rate of forward reaction gradually decreases. As a result, rate of forward reaction also decreases. Means concentration decreases, rate of reaction decreases. Means rate of any chemical reaction depends on the concentration of the reactants. After some time, as the concentration of SO3 increases, this time the product SO3 starts to decompose slowly into SO2 and O2. This is the time when reverse reaction is started. In this condition, when SO3 decomposes to form SO2 and O2, it behaves as a reactant, and SO2 and O2 are the products for the reverse reaction. Here you can see SO3 now behaves as a reactant and SO2 and O2 are the products formed by the decomposition of SO3. And this rate of formation of SO2 and O2 depends on the concentration of SO3. More the concentration of SO3 produces, higher is the rate of reverse reaction. But at a certain point, when rate of forward reaction is equal to the rate of reverse reaction, at this stage, formation of SO3 and decomposition of SO3 becomes equal. This stage is said to have reached equilibrium state. Means the stage where both the rates, forward and reverse rates, become equal. Now explanation of this reaction is explained by diagram. Here you can see at the start we have only SO2 and O2. They both are the reactants. They chemically react together to form the SO3. At the start there is only a rate of forward reaction because there is no SO3. They both SO2 and O2 keep on reacting together to form the SO3. But at the point when SO3 concentration increases, at this point reverse reaction is started. SO3 decomposes to form SO2 and O2. When the reaction is in the forward direction, SO2 and O2 are the reactants. But when the reaction is in a reverse direction, that time SO3 is a reactant. And at the point where the rate of forward reaction and rate of reverse reactions become equal, that point is called a chemical equilibrium. And you know these reactions never go to the completion, so at the end we get the mixture of reactant and products. Here you can see at the end we get SO2, O2 and SO3. Now explanation of this reaction by a graph. In this graph you can see the graph is plotted between the time and concentration. At the x-axis there is a time and on the y-axis we have concentration. This graph is very easy to understand. If you observe the balanced chemical equation, you can see 2 moles of SO2 reacts with 1 mole of oxygen to produce 2 moles of SO3. So the ratio of both the reactants is 2:1. Concentration of SO2 is more as compared to O2. That shows in the graph. You can easily observe that SO2 concentration is greater than O2. And the SO3 is at the 0. That shows there is no SO3 at the start. As the reaction proceeds, the both reactants react together and start to consume to produce SO3. So concentration of SO3 gradually increases and concentration of O2 and SO2 decreases. Here you can see. At the start there is only a rate of forward reaction, but at after some time rate of reverse reaction also started. But here you can see this is the area where there is no change in the concentration. Reaction doesn't stop. Molecules keep on reacting continuously, but there is no change in the concentration. When there is no change in concentration is observed, and this is the point where equilibrium is achieved, and these shows the concentration SO3, concentration of SO3, SO2 and O2. These are the concentrations of reactant and products at the equilibrium, and this shows the chemical equilibrium is achieved between the forward and the reverse reactions. I hope students you have understood this graph.